here is the solution to the circular motion girl on the scales question. And the question begins, explain why a body moving at constant speed in a circular path needs a resultant force acting on it, for 2 marks. Well, the velocity is changing since velocity is a vector. You might say there's 2 points, but therefore it is accelerating. I know I spelled that wrong. And that indeed. So there's my 2 points. I feel I have to say this, even though it looks like a second point. I need to get to the point where the next line would be, so there is a resultant force, which is in the question, so there's no credit for it. So velocity is changing. Since velocity is a vector, you might just say velocity is a vector, therefore it's accelerating. But I think I wouldn't feel comfortable saying any less than all of that. B part 1. Then we have a girl standing at the equator is in circular orbit about the Earth's axis. Calculate the angular speed of the girl. Well, the period of rotation here is 24 hours, which is 24 times 60 times 60 seconds, of course. And we know that the angular speed omega is 2 pi over t. I didn't really want that over there. Let's see if we can move it over. So omega equals 2 pi divided by t. Let's make that the pi it ought to be. So we have 2 pi divided by 24 times 60 times 60, and here we have this in symbols again. Let's get rid of that. Okay. Okay, and that will give us the answer 7.3 10 to the minus 5 radians per second. So there's my per second there, and my 10 to the minus 5 there. So there it is. And that's a familiar number, the angular speed of anything rotating around the Earth at the Earth's given radius. Obviously the radius of the Earth changes because it isn't actually a sphere, but it is a geoid, Earth-shaped. So there's the answer to B part 1. B part 2 then. The radius of the Earth is 6,400 kilometers. The girl has a mass of 60 kilograms. Calculate the resultant force required. Well, we have F equals mv squared over r. I'm just going to leave that there. And we have the angular speed rather than the linear speed. So let's convert that to F equals mr omega squared. And if we put in our numbers, we've got 60 times the radius, which is 6400,000, that's meters of course, times the angular speed, which was 7.3 times 10 to the minus 5. Squared. And that gives us 2 newtons is our answer there. So you see how the question is developing. And then down here it says, if the girl were to stand on weighing scales calibrated in newtons, what reading would they give? This is an important point that this is illustrating to us. If the girl was stationary, if she was not performing this circle, then the reading on the scales would be her weight, which would be mass times gravity. But she is moving in a circle, so something is different. Now, if you think about the car over the bridge, when the car was parked or the van was parked on the top of the bridge, the reaction and the weight were the same. But as the car began to drive over the bridge and perform that circular motion, then the reaction got less. So it is the reaction of the scales on her that is getting less. So if the scales are reading the reaction rather than reading her actual weight, then the scales reading will fall by 2 newtons. And if you think about it, if you were to stand on a set of scales in a lift, when the lift was to move down, initially to accelerate down as it moves off, the reading on the scales would fall. If you think about the extreme circumstance of the lift cable breaking, the reading on the scales would fall to 0. Think about that. But that's the case here, that you have 60 times 9.8, which is her weight, minus 2 would be the reading, which would be 586 newtons. That would be the value of the reading on the scales.